All right. So in this video, we will be discussing linearity and superposition. Now, for the fact of matter is that Schrodinger's wave equation is linear in terms of the wave function psi. That means every term that we have in Schrodinger's wave equation is associated with the wave function psi. That means if we come up with two solutions of a Schrodinger wave equation, the combination of these two solutions can also lead to a solution of the Schrodinger wave equation. So what does that mean? Is that suppose psi1 and psi2, these are the two solutions that we obtain by solving Schrodinger's wave equation. And we can have psi as a combination of this psi1 and psi2. Now this psi can also be assigned as the solution to the Schrodinger's wave equation. So we should say that psi is linear. There is a linearity. The wave function is linear. So if wave function is linear, then superposition principle is a reality for the combination of the wave functions. In a way, superposition is valid for sound waves. In a way, superposition principle is valid for electromagnetic waves, is valid for water waves, is valid for light waves. In the similar fashion, superposition principle is valid for the wave function. Now, if we choose a simple situation out here, like a double slit experiment for electrons. Suppose this is the screen, and I have a source here giving electrons, monoenergetic electrons. This is slit 1 and this is slit 2. Now, if I close this slit S1 and I keep S2 open, I will get the intensity distribution like this. So the intensity distribution may be assigned to psi 2, I will call this psi 2. I will assign the wave function with this as psi 1. So it will be psi 1 square. So we can expect a distribution of intensity in this fashion if I'm closing the slit S1. Similarly, if I close slit S2 and I open slit S1, I expect a distribution of intensity like this. So here it must be probability density square, psi 1. Now, the fact of matter is that if I keep both the slits open, what should I expect? I should expect a situation like this. The distribution of intensity should look like this. That means I can write here psi 1 square plus psi 2 square. But the fact of the matter is that this is not the thing that we observe on the screen. What we observe on the screen is a diffraction pattern having maximos and minimos. Now, what should be the reflection? What should be the proper reasons that we are getting a pattern like this on the screen instead of the pattern that I have shown here? Now, in this case, you can see that we have simply added the probabilities. We can't add the probabilities. What can we add is the wave function. And we can assign superposition principle to the given situation. So in this case, the reality of the fact should be that this pattern is a result of superposition of wave functions. psi1 and psi2. And we should add these wave functions. So adding these two wave functions will give me psi1 plus psi2 and work out its probability density. On working out the probability density of psi1 and psi2, adding psi1 and psi2 first and taking its complex conjugate, multiplying them leads to the result, leads to the pattern of diffraction pattern on the screen like this, rather than this. So this is wrong. This should not be the result. This should not be the result, because here we are simply adding the probabilities. What we are supposed to add is the wave function, because wave function is linear. It's linear in consolation with Schrodinger's wave equation. So combining the wave functions linearly, taking its complex conjugate and calculating the probability density for this situation leads to the diffraction pattern that we observe on